Systems of linear equations. So linear equation, that's just a line. Systems of linear equations, that's two lines. There we go. When we say that we are solving a system of linear equations, what we're saying is we want to find the point that works for both of these lines. We want to find where these two lines intersect, basically. So we're looking at the entire coordinate plane and we're saying, is there a point, x, y, that is on both of these lines? Which the only way that happens is if they cross over each other. So think about where Ashley Vasvate and Dorchester Road cross over, like when we talked about intersections. There's a point where they cross, right? And so that's what we're looking for with these linear equations. Where do these two lines cross? So naturally, the first way that we start to solve these is by graphing, because visually you can see where they cross. Graphing is limited, however, because with graphing you have room for error, meaning the way I draw the line, if I didn't draw it straight, whatever. If you're using just graph paper. If you're using a graphing device, then obviously you can walk to it, but it's still actually more of a pain, I think, than algebraically solving it. So graphing is a way to visually see where you're going to cross. And then we're going to actually look at other ways to figure out if we're not going to graph it, then how are we going to figure out where they cross? So the first way is just graphing. They actually give this to us in standard form. We've graphed in multiple ways. We've graphed in slope-intercept form where you plug in the intercept and then you walk up with the slope, right? And then if they give it to us in standard form, it's usually easier to graph using the x and the y intercepts. And all that means is where they cross the x or the y axis, all right? And so we're going to graph this one using intercepts because it's easier if it's already in standard form. So let's look at the first one. We have 3x minus 2y equals negative 6. That's my first line. So 3x minus 2y equals negative 6. If I want to figure out where it crosses the x-axis, I am going to zero out the y, okay? Which means I am just going to take the y and plug a 0 in, and that will tell me where it crosses the x-axis. So when I do that, I just get 3x equals negative 6. I zeroed out the y. If I want to find where the y-intercept is, I zero out the x. So I would get negative 2y equals negative 6. So x-intercept, zero out the y. Y-intercept, zero out the x. And so I would divide by 3, and I would see that my x-intercept happens at negative 2. It is a point, however. So that is negative 2, 0, because I zeroed out my y, all right? For my y-intercept, divide by negative 2, I am going to get y equals 3. But remember that is a point, so it is actually 0, 3. I zeroed out my x. So those are my 2 points for this line, all right? And so I am going to go to those 2 points. I'm going to go to negative 2, 0, and I'm going to go to 0, 3. And that is where I'm going to draw this particular line. So I'm going to say, okay, we have a line that goes through these points here. And so that is the graph for this particular line. Goes through those 2 points, all right? Let's look at the next line. The next line is x plus y equals negative 2. Well, this is really simple when you zero out one because you don't have any coefficient. If I zero out the y, I get x equals negative 2. Remember, it's a point. I zeroed out my y. If I zero out my x, I get y equals negative 2. It's a point, so my x value there is 0. So for this one, I go to negative 2, 0, and 0, negative 2. And then I am going to draw a line for this one, right, that goes through those 2 points. All right, and so I have graphed my 2 lines. I've graphed my first line, I've graphed my second line, and where they intersect is my answer of this system of equations. And they were nice, and they gave me the intersection right here on my intercept. So my answer for this particular problem would be at negative 2, 0. That is my answer. Can I check it? Can I check to see that that's the right answer? Yes, I can plug in negative 2, 0 into those 2 equations, and it should be a true statement. So if I plug in a negative 2, 0 up here, 3 times negative 2 is negative 6, minus 0 equals negative 6. That is true. Plug in a negative 2 here. -2 plus 0 equals -2. That is also true. So I know that this is where they cross, and that is my right answer for this. All right, when you're graphing like this, you start at your B. Your B is your y-intercept. So for this first one, my y-intercept was -2. My 5 in front of the x tells me how to move. I'm going to go up 5 and over 1. And so that's where I'm going to place this particular line. Oh, it's moving on me. I'm going to have to move him. He is not where I want him to be. There we go. All right. And then for my next one, I'm going to start at +5. And I'm going to go down 2 and over 1. And then draw that line.
Okay.
All right. He also is not exactly where I want him to be, but that's okay. It's hard for me to grab this, just the line. All right, you get what you get what I'm trying to do here.
I see.
It's like not letting me grab it. Close enough. All right. And then you can see that it's going to cross right here, right? So my answer here is going to be 1, 3. 1, 3 is my answer. All right, let's look at solving by substitution. So with substitution, this is easiest when you have a variable pretty much by itself, okay? And you really want to get the variable completely by itself and then substitute into the other equation for that variable, all right? And so when you have something like this, you just pick the easiest one. So I'm going to look at all my variables, my 2x, my 3y, my 5x, and my -1y. And I'm going to say which is the easiest to get completely by itself. And for me, that's going to be the y in the second equation, right? And so I am going to leave the first equation alone for just a minute, and I'm going to just deal with this equation right here. And I want to get rid of everything that is not with the y. So I'm going to subtract my 5x over. -y equals -5x plus 14. And then I'm going to divide by that -1. Just divide everything out. Y equals 5x minus 14. All right, 5x minus 14. So now I have one of my equations that has the variable all by itself. And once I do that, I'm going to take this piece of it, what the y equals, and I'm going to plug it back into my top equation, or the one I didn't use, for that variable. So I'm going to replace my y with that variable. So then I will take my first equation, I'll say 2x plus 3, and instead of y, I am going to write what I solved for y to equal, which is 5x minus 14. And that equals 9, all right? That equals 9. And then I can just solve it. I have a one variable equation that I can just solve for. So I'm going to solve by distributing this 3. 2x plus 15x minus 42 equals 9, right? And then combine my like terms, 17x minus 42 equals 9. Add my 42 over. 17x equals 51. And then divide by 17. So I have x equals 3. Now, I need a point, meaning I need an xy to have an actual answer. So since I have this x, I can plug it in over here to figure out what y equals. So y equals 5 times 3 minus 14. That is y equals 1. So my point here is going to be 3, 1. Solving by elimination. Elimination is also called solving by addition. You basically are going to add the two equations together and eliminate a variable. So the first thing you want to look for is, can I eliminate a variable easily? And so with decimals, it's kind of a pain to see a little bit. So I would probably get rid of my decimals first. They did not. They just went with it and didn't get rid of your decimals. Yeah, they just got rid of the y. So it just depends on whether you're comfortable dealing with decimals.
If you leave the decimals.
There's actually two ways to get rid of decimals. Since this is a 1.5, you can actually double both of the rows and it'll get rid of it. So if I doubled the entire row, I'd have a 3 and a 5 there instead of a 1.5 and a 2.5. That's one way to do it. Or you can just shift all the decimals over 1, like you're multiplying by 10. So I have 1 decimal place there, so I can just shift every decimal over. If you do it that way, though, you get big numbers because you'll get like 20 and 200. Yeah. So it's just up to you. I will tell you, the book just goes with it. They don't get rid of the decimals at all. So either way, you can do it. If we don't get rid of the decimals at all, I can show you how to do it before you divide so that you don't have to worry about decimals when you're dividing. So what the book does here is they get rid of the y. Now, what you're looking for with elimination is the path of least resistance. So I'm going to say, what is the easiest variable to make the same coefficient? So my x coefficients are 1.5 and 2.5. Even if those were 15 and 25, those are not easy ones to eliminate because you're looking for your least common multiple of those two things. And that's big, okay? But between 2 and 5, the least common multiple is 10. And so I could make those both 10, and then when I add down, it'll eliminate. Now, in order to eliminate, one has to be positive and one has to be negative. For in this case, one already is positive and negative. So we're going to do it the way the book did it, and then I'll show you how to get rid of the decimals at the last step, okay? So what I'm going to do is I'm going to take this top one, and I'm going to multiply that whole entire group by 5. And I know that my 2y will turn into a 10y. And then I'm going to multiply the entire bottom by 2. And I know that that y will be a negative 10y. And that's exactly what I want to happen. All right. So I'm going to take this 5 and I'm going to multiply it through every piece of this. And I'm going to take the 2 and do the same exact thing, every piece of that. All right. Just like I was distributing. So 5 times 1.5 is going to be 7.5x. 5 times 2y, that is 10y. And then 5 times 20, that is 100. And then I'm going to do the same thing with the bottom. 2 times 2.5, that is 5.0. 2 times negative 5y, that is negative 10y. And then 2 times negative 25 is negative 50. All right. So my whole goal with elimination is to make one variable the exact number just opposite of each other. Positive 10, negative 10. All right. And then when I do that, I'm just going to add straight down. 7.5 plus 5 is 12.5. Positive 10 and negative 10, those cancel each other out. And then 100 plus negative 50 is 50. Okay? Now, if you're using a calculator, we're good to go. 50 divided by 12.5 is 4. If you're not using a calculator, you can shift that over and do 500 divided by 125 is 4. Whatever's easiest for you, all right? But my goal here is to solve for x. 12.5 divided by 12.5. X equals 4. Once again, I need a y, okay? I need an x and a y for it to be an answer. So you can go back to either one of these equations and plug that 4 in for the x and solve, all right? You can plug it back in and solve, all right? And so we're going to get 6 plus 2y equals 20, 2y equals 14, y equals 7. So my answer here is going to be 4, 7. All right, so we have 2x minus 3y equals 1. 4x minus 5y equals 7. Which variable is the easiest to eliminate?
2x and 4.
The x's, right? Because I actually only have to multiply one of my equations here. Because I have a 2 and a 4, I can actually multiply this equation all by -2. And I will have a -4 and a +4, which is what I want. So -2 times 2x is -4x. -2 times -3y is +6y. And -2 times 1 is -2. The most common mistake is people don't multiply all the way across the equal sign, okay? You have to multiply every single piece by it. The second equation I can leave alone. 4x minus 5y equals 7. All right? Now that I have those, I can just add straight down. -4x and +4x will cancel. 6y minus 5y is just y. And -2 plus 7 is 5. All right? So I have my y. I can plug it into either equation to get my x. 2x minus 3 times 5 equals 7. 2x minus 15 equals 7. Then 2x, what was my answer here? 8? Oh, I wrote it wrong. Oh, there we go. I was like, I am getting the wrong answer. It helps to write the equation right. That's 1. There we go. 1. 2x equals 16. X equals 8. All right. 8, 5. Yeah. Make sure you write it in the right order. All right. So solving a system with 3 variables, you're really just eliminating variables and then backing back into your answer. So just like you did with 2, you eliminate one variable, solve for the variable, plug it back in to solve for the other one. Here you're eliminating more than one variable is what you're doing. And so you take the easiest variable to eliminate. There's a couple ways that you could do it here. I think they eliminated the x first or the z. I personally would probably do the z, but either way you can. So you're going to look again for the path of least resistance. Like when I'm looking at this one, I'm definitely not going to pick the y because the y is a pain. The x, I could multiply like 1 by 2, -2, and then do like -4 if I wanted to. You're basically taking 2 at a time and eliminating one variable. So you're going to pick 2 equations and eliminate a variable, and then you're going to pick 2 different equations and eliminate the same variable. And so if we went with like z, okay, let's say we chose to eliminate z, then I would pick the first 2 equations here to work with. So I would pick these 2 equations first and work with them. And I would say, okay, x minus 2y plus z equals 15. And 2x plus 3y minus z equals 7. So I'm picking z because I already have a positive and negative here, right? And so that makes my life a little easier. And so I can then just add those 2 up. And I will eliminate z. X plus 2x is 3x. -2y and positive 3y is y. My z's eliminate. 15 and 7 is 22. Okay? And then what I'm going to do is I'm going to pick 2 other equations. So I don't want to use the same 2 other ones to eliminate z as well. So this time I know I have to eliminate z because I just did. And so I'm going to pick the first and the last one because it's already a positive and negative. Okay? So this time I am going to choose the first and the last one because that will I won't have to worry about negatives. So I'm going to choose this one and this one to eliminate this time. And so for this one, I'm going to say, well, x minus 2y plus z equals 15. And 4x plus 10y minus 5z equals -3. I need the z's to be a positive and negative of the same number, okay? So I am going to multiply the top one by what to eliminate that -5z?
5.
Yeah, so I'm going to multiply this guy by 5, all right? Multiply him by 5. So I will have 5x minus 10y plus 5z equals 75, right? And then the bottom I'll leave alone. 4x plus 10y minus 5z, this is interesting, equals -3. All right? So that's going to help me a lot here, right? I'm going to add these up. 5x and 4x, 9x. Look what happens to my y's here. My y's cancel, right? And my z's cancel. 9x equals what? 72. I can actually go ahead and solve for x, can't I? What is x? Yeah, x is going to equal 8. Now, I already know x is 8. I have a 2-variable equation with an x and y. I can plug it in here. 3 times 8 plus y equals 22, right? Solve. So I can just say 3 and 8 is what?
24.
Plus y equals 22. So what is y? -2. So now I have an x and a y. And I can go back to any one of these equations with an x and a y and a z, plug in my x and y, and then I will get my z. So I can say x, well, x is 8, minus 2y, well, y is -2, plus z, I don't know z, that's what I'm solving for, equals 15, right? 8.
8 minus 4.
What's -2? So minus a negative, right?
So it's 4.
Yes, no, maybe? It's plus 4, right?
Yes, ma'am.
There we go. Plus z equals 15. This is going to be 12, so z is going to equal 3. So my final answer is x, y, z. All right, makes sense?
Yes.
Possibly. All right, so let's try one.
Wait.
We are going to try number 20 on page 22.
H12.
Yeah, P22.